All right, let's just get right into it. We've literally all been there. You know that universal Sunday morning disappointment? The kitchen smells absolutely amazing. You mix up a fresh batch of batter, pour it onto a hot griddle, flip it with total anticipation, and then, instead of this glorious cloud-like disc, you get a dense, rubbery hockey puck that actually fights back against your fork. It's heavy, it's chewy, and honestly, it kind of ruins the whole Sunday vibe. But what if I told you that achieving the ultimate fluffy breakfast has absolutely nothing to do with luck or some secret family magic? It is pure, measurable science. Welcome to This Explainer. This is your ultimate guide to fixing the flat pancake problem using chemistry, physics, and some hard data. Here's a quick look at our agenda for today's Pancake Science 101. We're going to cover the flat pancake problem, the chemistry of fluffiness, fat and gluten dynamics, perfecting your batter technique, and finally, a showdown between homemade and store-bought. Okay, let's kick things off with section 1, the flat pancake problem. Let's look at those everyday kitchen disasters we've all faced. It really is the central question of the breakfast table, isn't it? Why does our beloved breakfast treat so often turn out flat and sad instead of light and airy? Like, what exactly is going wrong between the mixing bowl and the plate?
Well, to fix a problem, we first have to understand the mechanics of the failure.
According to the culinary experts over at the Loveless Cafe, we usually fall into one of 4 really common traps. First off, you might just be using the wrong flour. Reaching for a high-protein, all-purpose flour gives you a completely different structural result than a softer, lower-protein cake flour, which yields a much more delicate texture. Or maybe you're overmixing the batter, which, let me tell you, is an absolute cardinal sin in pancake making. We'll uncover why in a minute. Maybe you're hungry and impatiently skipping the resting phase. Or finally, you might be cooking on a pan that's either scorchingly hot, burning the outside while leaving the inside raw, or far too cool to actually trigger the necessary reactions. This right here, this is our knowledge gap, and we're going to fix every single one of these issues with hard science. Moving right along to section 2, the chemistry of fluffiness. We really need to shift our focus to the literal chemical reactions required to create lift in that batter. Ultimately, this all comes down to leavening. A leavening agent, like baking soda, is basically a chemical that needs 2 very specific things to wake up and activate: an acidic ingredient and heat. When you introduce an acid, say the lactic acid naturally found in buttermilk, to the basic baking soda, a pretty violent, invisible reaction occurs. Now, it's actually kind of funny to think about this aggressive chemical reaction happening right in the middle of your peaceful Sunday morning kitchen, but that's exactly what's going on. The mix rapidly produces carbon dioxide gas, and then when that batter hits the hot pan, the heat accelerates the gas expansion. These tiny carbon dioxide balloons get trapped inside the solidifying batter as it cooks, and that's what creates that necessary vertical lift without making the actual food dense. Just check out the difference between the blue and orange bars here. This is actually straight from a fascinating peer-reviewed study published in the Journal of Emerging Investigators. The researchers wanted to test a really specific hypothesis. If they added homemade buttermilk and extra baking soda to a standard commercial just add water pancake mix, would it physically alter the structural height of the final pancake? The blue bar represents the control group, just the normal mix, and the orange bar represents the altered mix, spiked with that extra acid and leavening agent. And wow, the data here is just undeniable. Those experimentally altered pancakes were, on average, exactly 2.4 millimeters taller than the control group. Now, I know what you're thinking. If you're building a house, 2.4 millimeters is literally nothing. But in the microscopic structural baking world of a single pancake, a 2.4 millimeter increase is a massive, highly noticeable jump in volume, fluffiness, and overall airiness. Which brings us to the statistical heart of the experiment. Look at this number. P equals 0.0001. In scientific research, a p-value this incredibly low means there is profound statistical significance. It completely rules out a fluke. This means you don't need a lucky spatula to get fluffy pancakes. You literally just need to balance your chemistry. Fluffiness is a factual, repeatable, measurable result of matching acidic and basic properties. Let's jump into section 3, fat and gluten dynamics. Now that we've got our air bubbles, let's talk about the structural network that holds them in place. Okay, prepare to abandon everything you thought you knew about your pancake flavor profile. When you think of a pancake, you almost certainly picture a melting pat of butter. It's traditional, and yeah, it's super flavorful. But if you want the absolute optimal cloud-like texture, science points us in a very different direction. Comparing solid butter to liquid vegetable oil reveals a stark contrast. See, butter contains around 15 to 20% water, plus specific milk solids that can actually encourage a tough, chewy texture in your final bake. Oil, on the flip side, is 100% fat. It coats the flour in a completely different way, giving you a much more tender, incredibly moist result. Culinary creator Ethan Trubosky really hits the nail on the head here after his own extensive kitchen recipe testing. He notes that oil efficiently coats flour proteins, preventing strong gluten networks from forming. Why does this matter so much? Well, think of gluten like a microscopic elastic net. The more you work it, the tighter, stronger, and chewier that net gets. Because oil creates this slick, liquid barrier that physically stops that gluten net from forming and tightening, it allows the batter to hold on to way more hydration. Less gluten equals more retained water. And more retained water equals a pancake that basically melts in your mouth instead of one you have to aggressively chew. Moving right along, section 4, perfecting the batter technique. We have our baking soda and buttermilk producing carbon dioxide. We're using oil to stop the gluten. Let's transition to the actual physical execution. Before we even get near the stove, we really need to talk about the bowl. It is absolutely essential that you do not overmix. Actually, scratch that. You want visible, dry lumps in your batter because they hold pockets of extra air and prevent the whole thing from becoming overly runny. But once it's loosely mixed, patience is a scientific necessity. You've got to let the batter sit undisturbed for anywhere from 5 to 30 minutes. During this resting window, 3 distinct things are happening at the exact same time. First, the dry flour hydrates, properly absorbing the liquids so the batter thickens up. Second, whatever minimal gluten you did accidentally activate gets a chance to relax back into a tender state. And third, it gives those leavening agents the time they need to evenly distribute their tiny carbon dioxide bubbles throughout the whole bowl, which ensures a perfectly even rise. Let's build on that with some advanced techniques gathered from global culinary experts, including sources like Tudo Gustoso and Apitado do Pai. To lighten the heavy protein load of your flour, try this totally brilliant Portuguese trick. Swap out half of the flour for pure cornstarch. This makes sure the structural network doesn't weigh the batter down. Next, separate your eggs. Beat the egg whites into snow with a tiny pinch of salt to create a stable foam, and then gently fold it in from the bottom up to keep all that beautiful trapped air intact. Oh, and whatever you do, please step away from the blender. Mechanical blending will completely destroy everything we just talked about. A blender is essentially a high-speed gluten-activating machine. It's going to ruin all your hard work in about 3 seconds. And finally, section 5, homemade vs. store-bought. It's time to address the elephant in the kitchen. With all this talk of resting phases and folding egg whites, is making pancakes from scratch really worth the effort? If we break down the data from the food science platform Food Crumbles, we see a massive difference across these 3 methods. A totally homemade batch relies on recognizable, fresh, wet ingredients, milk, eggs, and basic flour. The dry pre-blend mix? Well, that requires all the water to be removed for shelf life, substituting fresh dairy and sugar with heavily processed whey powder and glucose syrup. But look over at that ready-to-heat column. To survive the long journey from a mass factory to a grocery store shelf, it relies on fractionated butterfat, various E-number preservatives like potassium sorbate, literally just to stop mold growth, and chemical thickeners like xanthan gum to keep the artificial oils and water from separating. But how do all those factory chemicals actually translate to what you're eating? Just look at this massive spike here. When we compare the fat content per 100 grams of these different methods, the difference is absolutely staggering. A standard, highly controlled homemade recipe sits at about 2 grams of fat. The dry pre-blend mix is pretty close at 1.5 grams, but the ready-to-heat microwavable convenience pancake, it contains a whopping 11 grams of fat per 100 grams. You're paying an incredible premium, both financially at the checkout line and nutritionally in your daily diet, for the ultimate hidden cost of that quick microwavable convenience. Which leaves us with one final, very important question to ponder. Knowing what you know now about the delicate, violent dance of lactic acid and baking soda, the absolutely crucial moisture-retaining properties of vegetable oil, and the vital structural importance of the resting phase, is the convenience of a store-bought, heavily processed mix really worth sacrificing the science of the perfect homemade fluff? The power to create the ultimate, towering, melt-in-your-mouth pancake is literally in your hands now. So are you going to settle for flat convenience, or are you going to put this science to the test in your own kitchen tomorrow morning? Thanks so much for watching this explainer, and keep exploring the amazing science hiding in plain sight.